Yeah. So hey guys, Himanshu here again. So today, like the first time we met, we looked into the basics of React Native. So today we'll continue that, and today we'll mostly focus on how to render large lists. Right. So usually, what you do is you have a lot of data, and then you format that data into some sort of a UI, some card, some basically some card or something like that, right? And then you uh, map it and show a lot of them. So this is what we'll do in React Native. So this is like pretty standard stuff. There's nothing too complicated about it, right? But there are certain differences between what you can do in the web and what you can do in React Native. Like it's the same thing, but the way of doing it is different, right? So this is what primarily I'll be talking about today. Before that, like one last topic that I wanted to discuss was how do you target native code? So let me just start sharing my screen. Right. So yeah, like I said, the agenda today would be learn to write platform specific code. Platform specific code means, let's say are building an iOS app as well as Android app, right? Now you want some code that runs only on iOS and you want some code that runs only on Android. So that is what I mean by writing platform specific code. The second thing is learn about displaying large lists. So like you have the map method, like dot map, like you have an array of objects and then you map over it, right? So this is one method. You have scroll view, you have flat list. With the help of flat list, we can have infinite scroll and stuff like that. So flat list is pretty cool, right? We'll get to this. And then section list. Section list is very similar to flat list, just it has two, like when you have data in form of sections, you prefer section list over flat list, right? So flat list can do pretty much everything, but section list is just like a convenience wrapper over flat list. So that's what section list actually is. Okay. So the first thing we'll do is write platform specific code. So how do you write platform specific code? Well, there are two ways. The first way is like both of them are pretty simple. So the first way is using a platform object, right? So like this is a basic React Native code. I'll just run this. Right. So what like it's basically building. Okay, and I'm running this on Expo only. So yeah, you can see this is the simulator and Expo is starting up. Uh, using Android. Okay, the simulator is not working properly, I think. Yeah, so yeah, so what I was saying is you can use platform. So you get a platform from React Native itself, right? And then using this platform, what you can do is here you can check key if platform.os is like you can see Android, iOS, macOS, web, Windows, and so on. So we only care about Android and iOS. So if this is an iOS platform, just console dot uh, log I am iOS platform. Okay, I am on iOS platform. Right. So this is how you can target like native code. Okay. Yeah, you can see this the log over here. I'm an iOS platform. So if I run the same thing on Android, like let me just run the same thing on an Android emulator. Yarn Android. Right. Okay. So this is the node version issue like I have. So yarn run. Yeah. So if I run the same code for Android, it won't work. Here, if I do platform versus Android, and console.log. I am on Android platform. Okay, so mm, yeah, it takes some time to start. Uh, yeah, so this is pretty much how you can target native code one way. This is like the first way. So instead of doing console logs, you can have like custom JSX. So if platform is iOS, render this JSX, or if platform.os is Android, render some other JSX. So this is how you can like code. So this is like the branching logic, right? Uh, Sorry. Okay. This is, yeah, this you sometimes happens because like running two emulators is like pretty heavy. So this does happen sometimes. Uh, Expo. Yeah, I think I need to kill this one first then. Yeah. So 100 bundling complete. Now I think this will work. Yeah. So yeah, you can see now this is running. I am on Android platform. Right. So this is how you can do. Uh, I can't. I think my computer can't run two emulators at the same time, so that might be an issue. But yeah, like this is how you can target specific code. Right. So this is the first way. So the second way of okay. Any doubts over here? Like anything you would want to ask? I think this is pretty straightforward, right? Okay. The second way is actually using a bundler, right? So what I mean by this second sort of logic on how to target native platform is suppose you have to import some library, right? And there are different libraries for iOS and Android. Now you want to run some code only for Android and you want to run some code only on iOS. So the first way is you can use the platform, right? But that branching logic like makes your code a lot more convoluted than it needs to be. So like what you can do is instead of having that branching logic, you can actually create different files that will be loaded when the specific platform is met. What I mean is, if you're running on Android emulator, it'll load the Android file. If you're running on iOS emulator, it'll load the iOS file. Like as simple as that, right? This I'll just show you how you can do this. So we write specific code using special file names. So this is purely done by the bundler. Okay. Does anyone remember what bundler we are using in React Native? We discussed this last time. Do you guys remember the bundler? Okay, I think no one remembers. It's called Metro. Yeah, correct. So it's Metro. So we are using Metro to do this for us. So what you do is you write your file name, and for Android you use dot Android dot whatever extension. Like I have written TS, it doesn't need to be TS. It can be dot JS, JSX, TS, TSX. Doesn't matter, right? And for iOS you do file name dot iOS dot TX. Again, this I have written TX, but it can be any of these over here, right? And then when you import this, you just import the file name. You don't add the extension. You don't even add dot Android and stuff like this, right? You don't do this. So I'll just show an example. Uh, Let me write some hello dot Android .js, right? So this is my Android file. So what does this do? This is just console.log Android. This is what it'll do. That's it. Uh, and then I'll make another file, which is called hello.ios.js. This will do the same thing. It'll just log, let's say, console.log ios. Right. So now what I can do is I can get rid of this logic. I don't need platform specific logic. Instead, what I'll do is I'll save this. I'll import. Uh, okay. Actually, this needs to. Uh, okay, I can't really do this. I need to export something, right? So function Android. Okay, function hello. Okay, I'll just write the JSX. That will be much cleaner. Import text from React Native, right? And I'll return text and do Android over here. Export default hello, right? And I'll just change the styles. Font size some 32. Font weight weight is some 700, right? I'll copy the same code in iOS, and instead of Android I'll just write iOS here, right? Okay, so now I'll import this hello component, hello from, yeah. So I need to get rid of this too. So this needs to be without any extension, and I'll render the hello component over here, right? So you can see this is logging Android, right? So I'll just run this on iOS 2. So again, very simple. What I've done is I've made it two files. The name of the file dot whatever platform what you're targeting, and dot the extension JS, TS, TSX, JSX, whatever. And then when you import, you just import the file name. You don't import, like, you import just the file name. Like, note here, I have not done hello dot Android or dot iOS, nothing like that. This is what Metro does for you. It'll figure out, hey, this is a platform that's running iOS or Android, and it'll import the correct file accordingly. So you can see this is how iOS is running. Okay, so any issues here? You guys want to ask anything, or shall I continue? So this is like the last way of how you can uh, manage platforms. Acha, and one last thing. Why are we doing this? Like, I hinted, like, we had different libraries for Android and iOS. So what you can do is you can create one folder for. Uh, I'll take a concrete example. Let's say you need to add notifications, right? So when you need to add notifications, there is a different way for Android, because Android uses Firebase, and Apple uses APN, Apple Push Notifications. So because these two are fundamentally different ways, but they are actually notification handlers. So you can make a file called notification.android.js. You can make a file called notification.ios.ts, and write all your notification code for Android and iOS in those files respectively, and import notification, so that you can have all the handlers set up according to what platform you're running on. So this is a much cleaner approach, instead of using platform.os, because you have to check if platform.os is this, set up this, else set up that. Instead, make two separate files and import the file that is actually needed, instead of uh, loading everything and checking files and stuff like that, right? Cool. uh, Anything else? Okay, so let's move on. So this is like how you uh, target native code, like target native code that is to be loaded, right? Now the second part is how do you render lists? Uh, okay, so render list may what I'll do is I'll just have some like sort of useless data over here. Okay, I'll just kill my Android. Yeah. So let's just have one simulator running because otherwise my laptop may hang and something like that. Okay. So what I'll do is I'll just make a data const data and let's have some colors, right? Red, blue, green, and I'll make some UI associated to it, right? So what I'm thinking is I'll just make a square and get the color from this data. Cool. So to make like a square, what I can do is okay, I'll get rid of all of this. Uh, Let me just commit this. I'll post the code later on so that you can have a reference to this. Um, Feature uh, platform specific code. Specific specific code. Uh, Commit. Yeah. So this is how you can write platform specific code. Now I'll get rid of this and yeah. The T is not. Yeah. Yeah. So now what I'll do is I'll create a view const color item. So this is just a view, right? And inside the view, this will be of size color item. I'll make the height as I think 100 and width as 100. Height 100, width 100. Okay, these are all in pixels and these are hard coded. So styles dot color item, and then to add the color, what I'll do is pass the color over here. So color item is now a component, right? So it can take in a background color prop, and this is what I'm passing this background color. Sorry, background color. Cool. So this is like my color item. So let me just test this out. Color item, and sorry, background color is, let's say, red. Yeah. So you can see this is a red square now. If I pass blue, this is a blue square, right? So let me just increase. I think I can make this 200, 200. Yeah, much bigger. Now, instead of justifying content at the center, I'll do this so that this is here. And instead of view, I can use safe area view, and import safe area view. Oh, sorry, view base. So safe area view is imported. Yeah, done. So like last time someone was asking what safe area view does is like this is exactly what it does. So if this was a normal view, you could see like the blue border over there. I'll just revert my code. So when this was a view, you can see it is rendering inside the status bar, right? This is your status bar. It renders inside it. So when you do the safe area view, it basically renders. Okay, sorry. It renders whenever the status bar notches and stuff like that ends, right? So this is why safe area view is what we use. Okay, so this is like the color item. Now the first is like to render a list, what you do is map, right? So it's the same. You just map. So what I do is data, sorry, data dot map for each I okay, for each data item. What I'll do is render this, and this should be data item. You can see. So now I have a list, right? I'll just make sure I add margins and paddings. Actually, margins only. Margin vertical, maybe something like 24. Yeah. So you can see it has gap now. Now let's add some more color. Purple, pink, right? Okay. You can see this purple is there, but there is no way I can scroll to it. Right? I'm trying to scroll, but I can't. Okay. So the issue here is, acha, any would like to guess like why can't we scroll? Any guesses? I'm not able to scroll. Any reasons why? Could be wrong. Like doesn't matter. Just a random guess. Like why can't we scroll?
The view can have the view has flex one, and its maximum is screen height. That
Okay. Okay. That's one way to say it. Need to wrap in scroll view. Yeah, exactly. So what happens is by default in web you get scroll bars, right? But here you don't get those scroll bars. To have scroll bars, like Ashwin has correctly stated, we needed a scroll view, right? So this is a map. Like this works exactly. Acha, one thing you need to note and remember is all items are rendered at once may cause performance issues for large list of data. Okay. So this is something we'll come back to, but for now, just keep in mind all the data that I have given, it is rendered all at once, right? So the issue is React Native doesn't give you scroll bar by default. So to get scroll bars, you wrap them in a scroll view. Cool. So in React Native, by default, scroll bars do not show up to make sure when content exceeds the view area. So you can see in our case, this content exceeded the view area. Scroll bars show up when we wrap list inside a scroll view component. Cool. So what I'll do is instead of doing this directly, I'll wrap this into a scroll view like so. Okay. Now you can see I can scroll now. Right. This is how you can add scroll bars. Then this can take a lot of props. Right. Scroll view is something when you Google scroll view docs React Native. Sorry, React Native. Yeah. So when you Google this, you can see it has a lot of stuff, like a lot of props. Some are iOS only, some are Android only, and like you can just get whatever props you can pass. But there are some props that are more useful than others, right? So there is a horizontal prop you can pass, right? So I'll just show. So if I pass this horizontal prop, you get uh, horizontal scroll, right? So this is your horizontal layout. So by default, it is vertical because everything in React Native is vertical, but you can make it horizontal by passing this horizontal prop. Cool. Then you have content container style. So I'll just briefly go through them. Content container style. Yeah. So this basically is a prop in which, so like how scroll view works is there is a wrapper around all of them, right? Because that scroll view wraps everything. So that you want to style that wrapper. So to style that wrapper, you can use content container style, right? You can see it will apply it to the scroll view content container. So the wrapper over all your mapped data is what you can style through this prop. Sometimes it comes in handy, but this is like a good to know that you can style those through this prop. Other thing is you have like a on scroll listener sort of callback. Yeah. So on scroll is like a callback, like it accepts a callback function and it gives you all of this. Right. So if you want to trigger something manually, or you want to know where in scroll somewhere is and stuff like that, so on scroll is your friend over here. So it gives you content offset, content length, layout measurement, and stuff like that. This is not typically used, but if you want to manually scroll and stuff like that, or you want to manually control scroll, this um, prop helps you over there, right? Uh, and then there is a scroll enabled. So this is also a pretty simple prop. So what I can do is scroll enabled is false. So I won't be able to scroll, right? So if you want to restrict scrolling, you can do this. So you can have a state and a button that toggles this state so that you can control whether you want on a press of a button whether you want your scrollable list to be scrollable or not, right? So this is your scroll enabled. So these are typically something that you may need. Okay. So horizontal is pretty straightforward. Scroll enabled is pretty straightforward. This is the container. You want to style the container. Now, why would you want to style the container? Because sometimes Flex doesn't work well with other styles. So you might want to style the container because usually React Native, what you might expect once doing something, it may not happen. There might be certain edge cases. So for that, it's easier to just add like usual issues with styling boils down to flex. So instead of doing flex one, try with 100, height 100, and stuff like that, because that may potentially fix the issue on its own. Because flex, grow, shrink is something that is not 100% reliable. Like I have not found them to be 100% reliable. Sometimes they do break. So when that happens, you can use width, height 100 and stuff like that. So when your UI sort of breaks, this is like what you should try to style and see what's happening. On scroll is something when you want to trigger some refetch and stuff like that on scrolling or something. So this is when you can use that. But there are better ways. Like the next thing what we'll discuss is flat list, which is much more efficient for that stuff. So yeah, this is the scroll view. Okay, any doubts over here? Okay, so okay, now one last thing before moving ahead. So map and scroll view usually work together. Why? Because map doesn't have scroll feature. So what you do is you have a scroll view and inside that you map the data. So these two usually work together. You typically would see a scroll view. If you see a scroll view, it is very likely to have a map inside it. Why? Because by default you don't get scroll bars. That's the only reason, right? So this is like the most important stuff in React Native. Like this is the basically stuff that you would use a lot in your day to day. Flat list, right? So flat list is something that basically does a lot of stuff for you, lot of stuff. So if you understand flat list, you are pretty much done with your UI side. What was discussed before scroll view? How to target native code, platform code. So I think there would be a recording, you can look at that. Yeah. So flat list is something that is like very, very, very important. So there is a concept known as windowing, right? If you search windowing in React, right? So I'll just if there is a GIF or something like that, I'll just check. Okay, this is not anything. Yeah. Okay. So windowing, what you mean is, uh, mm, mhm. Okay. So let me just go to. Okay. So yeah. So suppose this is your list, right? It has a lot of data. Sorry. Hmm. Yeah. So this is, let's suppose your list, right? And your screen is this big. So at this time, what you can see is just two squares. I'll just add some more squares, one on top and one on bottom. Yeah. So at a single time, you can only see two squares, right? So when you map, right, what map will do is it will render one, two, three, four, five, six, all of them. Map will render all of these squares from here till here. This is what map will render, right? So if you have 100 items, it will render everything from start to whatever finish. Cool. So this is what your map does. A better way would be using a flat list. So what flat list will do is you give it all this data, right? You give it all of this data so that it can make these corresponding boxes, correct? So now what you do is you have given flat list all the data, and flat list will implement windowing for you. What I mean by windowing is you can see only this in scroll bar. Sorry, you can only see this on the screen. So this is what it will render, this, and potentially one or two elements from here and here. So it won't render the whole list, it will just render what the user will immediately see. So if the user scrolls down, what will happen is your scroll bar moved from here to here, right? So because you scroll down, right? Now what will happen is flat list will remove these from memory in terms of the UI. Like the UI of this will be released, right? Freed up. The memory associated with this UI will be freed up. The data will be there so that it can generate this UI whenever needed, but the corresponding UI is actually removed. So now what's happening is you're freeing up memory whenever something is not in screen. And yeah, so basically that's much more efficient, right? Because you're only generating UI for what is to be shown to the user. So that is windowing. Yeah. So this flat list has a way of windowing. So it does that for you. You don't even need to specify how you want to window what, like it does that for you automatically. There is no need to do anything. Just add flat list and done. Like it implements windowing for you. So this is like a bit more technical definition of this. So it renders item lazily when they are about to appear and removes items that scroll way off screen to save memory and processing time. So this line is what I've picked up from the docs. So this is what they're saying, and this is what they actually mean. So any doubt on what windowing is and why we are using flat list? Yeah, it's exactly like lazy loading. So renders item lazily, right? Cool. Okay, so to implement flat list, what you typically do is, okay, so flat list is a bit more complex than scroll view. So scroll view inside you just added map, right? So flat list doesn't work that way. it needs two, three more props. So what it actually needs is, I'll show you. So instead of doing this map and stuff like this, so what I'll do is I'll implement include flat list from React Native, right? And I can get rid of this. Okay, I'll just commit this to header scrolling with scroll view. Okay, sorry, I need to add. Yeah, so this is what I need to do. I'll add flat list now. I'll get rid of this flat list like so. Okay, so what you do is here you would give whatever data you want to render. So I want to render colors, right? Data. So this is the data I want to render. So this is the first thing it needs. Second thing is needs is a render item. So render item mein you give what you want to render. So what I want to render is this color item, right? So just pass this over here. Color item over here. Cool. So this is okay. For now, I'll just hard code it to red. Sorry. Yeah. So now you can see like it's scrolling. Everything is red. Correct. So this is how you render stuff. Okay. This is like not the ideal way because like okay. Basically, render item. I'll just show you something once. I'll make this a callback and return this. Right. So render item you give whatever you want to render. So here you get some props. I'll just show you what render item actually gives you. So console.log props, if you see uh, over here, node, yeah. So you can see this is something that the props is, right. So it gives you index, it gives you an item. So apart from that, separators is something we don't worry about. Update props is something we don't worry about. The only thing we worry about is these two, index and item, right? So you basically destructure them over here. This is like the usual way. So you get an index over here and an item over here, right? So instead of props, I'll just render index and the item over here. So now you can just compare this with this. So on the zeroth index you have red, right? On the first index you have blue. On the second index you have green. So it's basically this list, nothing else. So flat list gives you your data, this data in item. So if this would have been something like color red, right? Color red. So you can see this is what is coming out of the item. So what your data is, exactly that is inside the item. Cool. Yeah. So for now, let's just keep it this, and instead of rendering this, I'll just render whatever the item is. And okay, this I don't need the index. I'll get rid of this. And yeah. Right. So now you can see the list. One more thing. There is called something like a key extractor. Right. So key extractor basically is a, like you can read this here. You used to extract a unique key. So what you typically do in React applications is you have something like key equals to something, right? Key equals to some value, some string value. So instead of doing that inside flat list, what you do is you add a key extractor prop and then you tell it how to extract the key. So by default, it gets this item and string, right? So I'll just show you. Let's just console log the props over here first. Console log props, right? Yeah. So these are the props over here. I'll just key extractor props. So yeah. So these are the props. So whatever data you have passed is what you get over here. So for me, what I'm doing is, since I'm making sure my colors are unique, I can use them as key, right? I'll just return this props to use them as key. So this is how you can add keys inside flat list. Okay, this is also working now, right? Hmm. So, like I said, key extractor to provide unique keys to the list items. Initial nums to render. This is the limit, the number of items list render. So you can have like how many items. Yeah. Does it throw the error of key? No, I didn't get the question. Does it throw the error of key meaning what? Like if you don't give it a key, no, it won't complain, but the rendering process would not, like it would complain, it would give you a console.warn or something like that, but it won't be that efficient because React needs the key to know what UI to update, right? So as much as you can help React, your performance would increase that much, right? It mentioned it before you spoke about key extractor. No, it doesn't really throw error about key. Like what it'll do is say something like console.warn, I didn't get key or something like that. Yeah. Like something like this. Warning each child in list should have a key or something like that. Yeah. So error, I think. Yeah. It needs a key prop. I think if I get rid of this, I'll get that. I'll just refresh this. Think I might get that warning again or not. Yeah, not sure. So yeah, you might get a warning, you might not. Like, let's just not rely on that, right? We know we have to add a key, and this is the way you can add a key in React Native. So just like this is how you can add a key in Flatlist. So just do that. Don't wait for the compiler to yell at you. Okay. Uh, cool. So yeah, initial num to render is what I was discussing. So React Native. So these are the official docs. You can search for flatlist over here. You will get it. Yeah. So here you have something called initial num to render. Right. So this is how many items to render in the initial batch. Suppose you have 1,000 items and you want to render 50 items in the first time. So you give initial num to render 50. From what I remember, by default, the initial num to render is 10. But yeah, yeah, the default value is 10. But you can change this. This should, like, as I said, if the items are very small, you would have a large default value because you want this value to fill the screen. As I said, this should be enough to fill the screen, but not much more. Why? Because if it is more, like the window would have to be larger, right? So our window was this, right? So this would have to be larger to, if you give a large number, so this window would have to be larger, right? And since the screen size is this much, the window size is this much, like you're obviously wasting some compute over here. You want your window size to be as small as possible for best performance, right? So that's why they are saying ki, this should be just enough to fill the screen. Yeah, list header components, list footer components are something you can use to add some headers and footers inside the flat list. You can try these out. Uh, yeah, this is something I need to discuss in detail. Yeah, but before that, any issues in flat list? Anything you would want to know or something? I'll just. Okay, so now what I want to do is like I have some custom code over here. Sorry. Yeah. So there is this dummyjson.com. If you just go there, this is just basically I need some dummy data. So that's why I'm here. Uh, yeah. So what I want is to implement infinite scroll. Right? You have seen infinite scroll in apps, right? That you keep on scrolling, more data comes. Keep scrolling, more data comes. Right? So this is what I want to show how you can implement that in Flask list. It is pretty simple, not very hard. But yeah, so from here I got one API, which is this one, dummy JSON to do's whatever. So I'll just copy paste this for now. Like I'll explain this code just a minute. Use pagination. So I'm creating a pagination hook, right? Use effect from React. Const use pagination. Use effect. Yeah. So here what I'll have is data const data set data, which is use state an empty array for now, and I'll return this data like so. Right. Now this is like the data fetch. Sorry, this is like the fetching logic. So I'll just explain this once. So this endpoint, I'll just search that over here. To do, yeah, this one. Where did that go? Random. Yeah. Okay. So this is how you implement pagination. So you can see this is the endpoint. Limit is like how many items you want. So if I limit them to 10, I'll get 10 items. If I limit them to 3, I'll get 3 items. Right. So this guy did 3. So he got one, 2, 3 items over here. Cool. So if I do a limit 7, I'll get 7 items. And skip is how many items you want to skip. So he has skipped 10 items. So the next ID to get is 11. So that's why he has gotten 11 to 13. So this is a pretty standard API for fetching paginated data. Infinite scroll is basically an extension of pagination. So if you can paginate your data, then you can infinite scroll it also. From the API side, the data that is being returned paginated, that is fine. The API side implementation is just the pagination. After that, the infinite scroll implementation is purely front end. So yeah, this is what I'll show you today. So what I've done is I've gotten that response, and then instead of response, you can see this is the JSON, right? So this to do's is something I'm interested in. This total skip limit, I don't care. I'm keeping track of limit and skip on my own. So I don't need the API to tell me what the skip is, what the limit is. If you want, you can use that. I prefer to keep that state in the front end because that's who the driver is. You don't want to rely on API skip and limit because what I think is this API can work without this data. So I don't want my backend to send me this data. If I was building the API or I was conversing with the backend, I wouldn't request these two data. Total is something, if it is required, you can ask. If it is not, you can get rid of this too. You want to get as minimal data from backend as you can, right? Okay, so this is what I've done. So you fetch this data. So I'm maintaining a limit on my own. So for now, I'll just const limit is 10. So this is what my limit is. And skip is basically the offset you want to skip. So I'll just explain this in a minute, like why I have done offset into limit. But for now, you can see I'll get this data. I'm converting it into a JSON and then setting this data. So as you can see in the API, the only thing I care about is this, right? So I'll just destructure that and append it to whatever the data previously was. So now it is empty. The first time it will fetch the data, it will get the to-dos and append them in this list. So you'll get 10 to-dos. And then next time what will happen is, next time when you fetch, you'll get another 10, because the limit is 10, you'll get 10 data. but that ID will be from 11 to 20, and I'll append that into this new array. So now the array will contain items from 1 to 20. Make sense? Uh, any doubts here? Like, I hope people know pagination at least. Yeah. So now what I'll do is, since I'm creating a hook, I want my limit to be variable. So limit is this limit, and instead of this, I'll use this limit. Why? Because this is a default parameter. If I want to change the limit, I should be able to change that through the one who's calling the hook itself, right? Technically, if I'm creating a proper hook, even this callback should be like this URL should be dynamic. But I think since this is a dummy project, I can do this sort of hack and get away because like I'm not gonna reuse this hook again. So yeah, this is what I'll do, and I'll get the offset, right? Okay. So offset is, instead of calling it offset, let's just call it page. Yeah, let's just call it page number. Yeah. So this is your page number. So during pagination, you have page one and you get 10 elements. Then on the page two, you get the next 10 elements. On the page three, you get next 10 elements. Right. So skip is basically how many items you want to skip. Right. So if you see, like, mathematically, initially page number would be 0, then it would be 1, then it would be 2, 3, and so on. Right. This is your page number. Page number. Now, your data IDs would be from 0 to, like, sorry, you won't have a 0 ID, from 1 to 10 on page number 0. Why? Because limit is 10 and you're telling to skip page number that is 0 into limit 10 that is 0. So you're telling it to skip 0 elements. So that's why you would, okay, I'll just add one more skip field over here. So skip would be 0 over here, then it would be page number into limit. So page number is what? 1. 1 into 10 is 10. So then you would get 10. Then next size page number would increase by 1. So you would be 20, and then your skip would be 20. Right. So this is how you would get. You would get 1 to 10 here, then you would get 2 to, sorry, 11 to 20, and then 21 to 30, and so on. Yeah. So this is like how the mathematics of this works. You can spend some time here if you don't understand it. Like, this is a normal pagination API. I'm not doing anything unique over here. Okay. So once I've done this, I'll just import the use pagination hook. Import use pagination. Sorry. I haven't, okay, I haven't exported this. Export default use pagination. Right. I'll import use pagination from here. Okay. So now I'll just destructure the data and use pagination. So limit is, I'm not passing the limit, I just need to pass the offset, oh sorry, the page number, right? So page number, now I'm passing it as 0, right? So let me just see if the data is coming. Console.log this data. Yeah. So you can see this is like what I'm getting. My data is with ID 1 to, I think, ID 10, right? If I pass in a page number 1, I should get ID 10 to, what is this, 19. Yeah. So yeah, basically one ID here and there, but yeah, that's fine. Okay. Page number, if I put 2 over here, I should get, what is this? Okay, I'll just clear this. Page number 3, what I'm getting is, okay, this is not properly cleared. Yeah, now it is. Yeah. Yeah, page number 2, you can see like this is what my previous ID 1 was. Okay. Why am I getting all of this data like 1 2 3? Because what I've done is I'm appending this to the previous data, right? So whatever previous data is there, that will still be there, but I'm appending new data too, right? So that's why I'm getting ID 1 2 3 also, and as well as the last ones from I think 30, like, whatever till 30. So this is how this hook is working. Good. So now to implement infinite scroll, what I need is I need to make some changes. Uh, in the meantime, any doubts here? So if you understand this, like the pagination implementation is very simple for flatlist. The main logic I've done is inside the hook, I'm giving it a page number and it appends the data of that page to the previously existing data. That's it. So if you understand that hook, what I've done in pagination is very simple now. The next thing what I will do is, so to implement pagination, uh, I'll just minimize this. Yeah. So there is an on end reached, right? So there is this thing called on end reached, right? So if I scroll to the end, this will get called console.log end reached, right? So okay, limit is undefined. I'll just comment this for now and comment this for now. Hmm. So like now I'm at the end of the list, right? So you can see this is triggered, right? So this callback is triggered whenever flat list reaches the end of a list. So this is getting called. This is one thing I wanted to show you, and yeah, that's pretty much it. So now what logic I can have is whenever you reach the end of the list, increase the page number by one, right? So in the use pagination hook, instead of doing this, I can change, like I need to rerun this effect whenever your limit changes or your page number changes. So that's why I've added two dependencies. So this effect will run whenever any of these change. So now what I'll do is I'll have keep track of page here. Page set page is use state. Initially the page number is 0 and const handle page update is use state. Sorry, this should be a callback. So what this will do is it will set page to the old previous page to page plus one. Okay, so I usually like these arrow functions instead of using this page directly because the setter, if you can derive the new state from the previous state, that is advisable instead of this, because if you pass this callback and you need to update some state, you would have to pass this also. If you can derive that from the previous state, that's usually much better than using this state. Cool. That's why I'm doing this. You can use page two, like page plus one, that is also fine, not an issue, but I prefer it doing it this way. Page number will be page, right? Okay, so okay, this is what is happening. Then I'll reach the end of the list, right? So now you can see I have till user ID 19. Oh, sorry, user ID 19. Sorry, ID is 9. Okay, okay. On end reach, I need to add that. Sorry, handle page update. Yeah. So now you can see it has a lot more data. So it's fetching it. So now I'll just get rid of this color, and instead of color, I'll just render this data. And instead of this color item, what I'll do is I'll render a text with. Okay, I'm just hard coding stuff. This is not how you should do, but I'm just doing this for now. This is just a demo project. So height 100, width 100, and font size maybe 32. Font weight. Let's just keep it at 18. Otherwise, it'll do font weight will be some 600, and then Here I have item. So inside the item, if you look at the API, this is what the item would be inside the list. So item dot to do is what I need to render for the text to work. Let's just check. Yeah. So this is what we are rendering. Right. Done. Yeah. So you can see now it rendered much more. I've hit it. Now it's rendering more. Right. Yeah. See, it keeps rendering more. I think now, yeah. Right. So see, it's infinite scrolling. Whenever I reach an end, it will render more. Yeah. So yeah, this is some key extractor issue, right? So I need to pass in proper IDs and stuff like that, props.id or something like that. Yeah. So yeah, because like these warnings are there because I've not set up keys and stuff like that properly. But once you do that, it should work. You can see encountered same with key and stuff like that. I'll just kill this, right? So because I'm returning props, which is an object, this is converted into stringified version. So stringified version is object, and it is using this key for everyone. So that's why like those like it was glitching. If I do this now, props.id instead of that, uh, yeah, let's just run this. Okay, I'll just open this in Android. Let's just kill this. Okay, this is like how you would implement infinite scroll over here. One last thing. This is like infinite scroll in the downward direction. So when you keep scrolling down, more data comes, right? You would have seen stuff like WhatsApp where you scroll up and you get more data, right? So to implement that, you just need to do one thing, just one thing. You go here and add it inverted. So when you do this, the whole list is inverted effectively, and then when you scroll up, you fetch new data because the end of the list is on the top, not at the bottom. Cool. So this is how you would do inverted prop for reversing the list. Okay, these are homework for you. Like if you want a challenge, you can look into these questions. So this question is something I don't expect you to be able to solve easily. So if you don't solve this question, don't be disheartened. This is pretty complicated, like a bit more complicated than normal flat list stuff. But if you can build this, like you know flat list very well at this point. Cool. So basically, you are building a bidirectional infinite scroll flat list. So what I've shown you is when you scroll down, you fetch new data. When you scroll up, you need to fetch new data. That can be done by using inverted, right? Now, I want you to build a flat list wherein when you go up or when you go down, I need you to be able to fetch new data. So, like, just go back to the windowing concept. So, think of it like you are starting from here, right? So, when you scroll up, there is this data over here, right? So I want to be able to fetch this data. When you scroll down, there is data over here. So I need you to be able to fetch this data. So this is what I mean by bidirectional infinite scroll flat list. This is the first question. This is pretty hard. This is something you should try. This is something I expect you to be able to build. So what I want you to do is get a static list of maybe 10, 20 elements and have a button, right? So on clicking that button, you should be able to scroll to any of the indices. So let's suppose you have ID 0, 1, 2, 3, 4, 5. Oh, sorry, you don't have ID 0. You have ID 1, 2, 3, 4 up till 10. So when I press the button, you should be able to scroll down to Windows 7 automatically. So the user doesn't need to scroll; it automatically scrolls down to the list item 7. So that index should be variable. Like if you put const id equals to 7, so it should scroll to that particular id. If you put id equals to 3, it should be scroll to that id. So this is something you should try, right? So you would scroll, like the hint to this is read upon scroll to index. So scroll to index is something you should see how you can do this, right? Also, this is, you can use a flat list, you can use a scroll view, like both are same uh, mm, because you're rendering all the data at once pretty much. So you can either use this flat list, would be more uh, like it would be more optimized, but a scroll view is also fine for this particular problem. Okay. uh, is this working? Okay, finally. Okay, I'm not sure why this emulator is not working now. Hmm. Yeah. Yeah, now it's working. Yeah, so this is what I've done. I've done inverted, right? So you can see the UI glitching a bit, but I am not really interested in the UI. I've added a constant height and width, right? So that's why it's breaking. But you can see when I scroll up, I'm getting new data, right? Also, and this time you can see that there are no warnings and stuff like that because I've given them proper keys. So this is why you need to give them proper keys. Okay, so like this is what I said about how WhatsApp scroll works, right? When you scroll up, you keep getting data. One last thing is pull to refresh, right? So I'll just get rid of this inverted. So pull to refresh is, uh, you might have seen apps when you do this, it sort of refreshes, right? So that is the pull to refresh. So this is also very simple. So what you do is add a refresh control, and you need to import refresh control as well. So there is some refresh control. So what you do is refresh control. So here there is a refreshing prop. So this should be true when is loading is true, something like this. Whenever it is loading, it is effectively refreshing. And then there is another, okay, sorry, refresh control. There is one other prop. I forget the name of it. Refresh control. Yeah. So on refresh event or something like this. Refresh control. Yeah. On refresh is the prop. So on refresh. So whenever user pulls down and refreshes the screen, I just want to basically do whatever you want. So for now, I'll just log. So dot log refreshing. Right. So I'll just show you here on the simulator. Yeah, is loading doesn't exist for now. So uh, const is loading is equal to false for now. Yeah. So yeah, so you can see this right. So this is pull to refresh. Whenever I pull, you can see this refreshing is done. So here you can actually manage the UI for loading and stuff like that. So this is your pull to refresh, right? Okay. Yeah, this is the last thing of the meeting today, section list. So I won't implement or show you any implementation of a section list because that again will take too long, but I'll just show you the basics of it. So in section list, to add custom support for sections. So if your data is in the format of header plus body, so the best thing you can do is look over here. So your data is in this format. So it has a title and it has a data associated. It has some title. So this title is actually the header, and then there is some data associated with this, right? So main dish is this. So this is somewhere you would typically use section list. Now, section list is same as flat list, like no huge difference, right? So if you don't need section support, use flat list. If you want section support, use section list. That's it. Here, just two, three props ka naming changes, nothing more. So instead of using data, you use a sections field. You can see here. So here passing in flat list, this would be something like data, right? So here it is not data, it is sections. Cool. So this is how you would use section list if your data is in this format. Yeah, that's pretty much it for today. Like if you have any doubts, please feel free to ask. Uh, yeah. If you have any questions, any doubts, please go ahead. Can you pass data in objects to flat list? No, flat list takes an array. Flat list, uh, the data to flat list can only be an array. You can't have an object passed to it. Like, how would you render a list of objects? The list of objects needs to be in an array, right? So that's why if you are passing data to flat list, it can be an array only. Does flash list implement caching internally? Okay. Uh, it might not. Let me just check once. Flat list implement caching. I'm not sure. It does windowing for you. Virtualization. Hmm. No, I'm not sure. I can't find anything about caching. But yeah, it does windowing for you. It might cache, it might not cache, not sure, Ronak. Okay, and one last thing. Uh, yeah, sure, you can unmute. Yeah, just one thing before you ask the question. There is something also called as a flash list. So I'll just flash list. Okay, I'll just share my screen again. So this is something flash list. Yeah, so this is a more performant flat list, right? So this is, I think, done by Shopify. Yeah, shopify.github.io. Yeah, right. So they have basically implemented a faster version of flat list. So this is flash list, and the props are same as flat list only. Like there isn't much difference. If you feel your flat list is slow, go ahead and try this. It could potentially improve your performance a lot. Like I've heard a lot of good things from my friends, but I haven't used it. So this is something even I want to explore. But yeah, you can check this out too. This is a better flat list. That is being said by Shopify. Yeah, sorry, Ronak, go ahead.
Okay, my question is, so when you were talking about windowing, so suppose if you are at a particular window, okay,
Hmm.
and you happen to scroll down, so that data which was loaded, like you said that it has lazy loading, right? So that
Hmm.
data, like, suppose you scroll to some other window, right? So
Hmm.
the window which was in the UI earlier and which is not in the UI as of now, so that data will again be loaded or will it not be loaded again?
Okay, one thing you need to know is, data is not lazily loaded. Data is there. Data is lazily rendered, meaning data is already there. That data to UI conversion, what React does, right? Data is converted into UI, that is done by React. So that is done lazily.
Oh,
So data is not lost. Data is always there. Only the UI that you build, right, that is not stored in memory or it is gotten rid of.
okay. Okay, understood. I
Got it?
misunderstood it, like because like you mentioned, it implements infinite scrolling, right? So
Yes.
in infinite scrolling, what happens? We don't load data at once. We use the concept of tokenization. So, but in this case, the data is getting loaded at once. So, yeah, I mean, it answers my question.
Right. So renders
Yeah.
item lazily, not the data. Data is already loaded. Items are rendered lazily.
So, see, suppose imagine a scenario where we have a lot of data.
Hmm.
So, calling an API which presents all the data at once will be like the API will not be much performant. So, in
Correct.
that case, what would you suggest if I want to lazily load the data as well? So, how can it be done?
I have lazily loaded the data, right?
Yeah, in your
Using
case, there was an
pagination.
API, right, for pagination.
Yes.
So suppose if this kind of offset and limiter is not available, then in that case,
I mean, you can't do much, right? The API is giving you all the data.
Mhm.
Like, there is, how can you tell your
ah,
backend to give less data? Like, that is something you need to have a conversation with your backend developer. Ki, hey,
backend thing, yeah, yeah,
this
understood.
is something I need to implement infinite scroll or lazy loading or stuff like that. If you don't
Mhm.
do this, I'll get all the data at the same time, but that will take a lot of time. Like the network call will be very heavy.
Yeah,
You like if they don't implement that mechanism of pagination, then you can't do anything. The thing you can do is you can go there and implement that and use the API yourself, but you can't do anything other than that. The API needs to support it.
not understood.
Yeah. Thanks for asking, Ronak. I think people may have misunderstood that part. So thanks for asking that.
Yeah.
Okay. Anyone else? Cool. Yeah, I think, okay. We'll most probably have a next session next Sunday. If I think I'll discuss it once with Swapnil. Next would majorly be on navigation and stuff like that. So you have multiple screens in your app. So how do you navigate from one screen to another and stuff like that? So that is the next focus. So after that third session, you should be able to build UI apps like React Native apps pretty comfortably. Like I've made sure like I've touched major concepts so that you are not lost at any point, but you need to put in effort from your side. So that's why I've given you like two homework challenges. So these are good questions for you to try and understand how it all works. You can try them. And yeah, next session will most probably be on navigation. In which case, should scroll view be used or fractal? Yeah. So scroll view now you should use when you know you have a finite set of data. Maybe you have some 50 entries, some 100 entries, and you're pretty sure कि, hey, this is the only amount of data I'll ever have. In that case, go ahead, use scroll view because it's simpler. The API is simpler for scroll view, so that is when you should use. But the other argument to this is like, why do you need scroll view? Always use flat list. That is also a correct argument. So see what works for you. The benefit of scroll view is it has a simpler API, so you don't need to pass in data, pass in render items, stuff like that. Cool. So scroll view you should use only when you know there is a finite set of data. That's it. If you know you have a lot of data, scroll view is not the solution. Not the solution. Yeah, if there are any more questions, you can feel free to ask. Otherwise, I think, yeah, we can stop the session now.